Good afternoon. Hope everybody's having a good day. Um, Interesting day for me. So I recently got a new job, and so I have a whole new like desk setup that I just put together. I'm not 100% on the setup for everything. For one, my monitor is not hitting full resolution. Um, so, uh, Not real happy about that, but we'll get through it today. It should be fine. And I don't know if you folks have seen my previous streams, but I was always downscaling my primary monitor so that the stream could catch everything and not drop frames and not look like awful. So I'm kind of dealing with the lower resolution anyway. But I'm going to try to do this. It's going to look a little weird probably because I have switched to a like double wide screen single monitor curved. So I'm going to try to put everything that we'll be looking at in the center. But that remains to be seen about whether that's going to work long term. So I think it'll be like better for me ergonomically, but we might need to make some adjustments in the future. And hopefully by next week have the full resolution set up and I'll be fully productive on it. The other thing is I made an announcement on the YouTube community section. If you have not seen it, do have a look. But I'm no longer on Twitter, and I refuse to call it by its other name. It's always been Twitter to me. So if you're looking for my announcements on Twitter, and you happen to come to my stream anyway, I'm no longer on Twitter. So please do not expect any messages about anything there. And anyway, this will be interesting. My cat is trying to kill some twist ties that came off of the new components I put together. And there's a group of painters across the street that are playing mariachi music really loud. So hopefully that won't come through on the stream too much. But let's get started. It's been a couple of weeks. So let me flip over, and hopefully that looks okay for you. If you do not see this clearly, please let me know. I'll try to make adjustments as we go. In the meantime, let's just go with it. So we are working on a port of HanoiDB in Rust. So HanoiDB is originally written in Erlang, and we've been working on it for, well, this is session 17. So it's been many months now. I think we started in June or July, and I've had a couple of weeks off. So putting in 2 hours at a time for that amount of time, I think we've done pretty well. So okay, we're gonna flip over to Zed. Now you may see there's a dark bar at the top. That is actually my title bar and menu bar. You will not be able to see everything because I've centered it. My apologies for that. But hopefully this is good enough for you all on the stream. If you need me to increase text size or whatever because my new monitor setup is weird, just let me know in the chat. Oh, and I get to click to restart and update Zed. Fun. Okay, we are up to date. Beach ball. That was not intended. Okay, things are not happy. We will restart Zed. For whatever reason, it went beach ball. Okay, so it was actually, I think, starting Rust Analyzer. All right, so previously, I don't remember if we did this time or like in the penultimate episode, or in the episode before, but we factored out things into different files so that we can more easily find things, and so that each file has less cognitive overhead. So hopefully we can go going on compression today. Now we had possibly looked at some of these things before, but the main things that the main compression methods that HanoiDB used or supported were snappy, gzip, and lz4. This is the original Erlang version enumeration here. Now I would like to kind of think about what the interface is here, because this is what we actually serialize into the file, saying this is the kind of compression we're using for this block. So if we look over here at the block, you note it has a compression. It has a compression field. So there's a bit at the head of the block that is not compressed and never will be. We need that so that we can so that we can know what the size of the contents are, and so forth, and what kind of, what level of the tree the block is at. And we, there's some bits here that we'll need to look at the design diagram to be sure, and the Erlang code. Let me see if I have that open. I do not. Let's make sure I have that open. HanoiDB. Okay, so here's the Erlang code, and hopefully that's lined up well enough. It gets stuck. That's kind of weird. Okay, so yeah, so we can look at the writer perhaps, and if we look at, I believe is probably flush node buffer. No. Okay, so encode index nodes, and is passing the compression there. So if we look at what this does, we'll jump down to encode index node. Okay, so we're basically using this format. We're not using this v-bisect, which I have to research some more. I think that was supposed to make scanning the file a lot faster. Okay, so it basically writes the whole thing, and then it compresses it with the compression method. So if we go to compress, right, so okay, so this is doing something interesting, which is it's saying if this does not compress to something smaller than the original contents, then turn compression off. So for all of these, right, and it's saying, hey, I'm using snappy, and here's the compressed binary. Or if it's not smaller, and this use compressed is probably a simple comparison. Right, so when compressed size is smaller than the uncompressed size, then it's true. So we get to figure out how to do this in Rust. So I think it would be good to look at snappy and see if there's a nice binding or a pure Rust version. Okay, so this one is pure Rust. This has a lot of usage. Note how many times it's been downloaded. This is just bindings to the Google compression library. I would be interested, that's 8 years ago. Let's look at this one. 12 months, that's much more recent. Give me just 1 second. My cat is getting into something. That was fun. So, okay. Let's have a look at this one. So this is ported from both the reference and the Go implementation. Its CI is failing. Okay, so it kind of implements the writer interface. Okay. But let's give this one a shot. I think that what we'll want to know is like what the interface is like. So we're using the standard IO write and read traits, which is pretty much expected. And then so it's got frame decoders and frame encoders. So this will be interesting with the way that we are using the file. I think that we'll want to figure out where this needs to be injected and create an interface, maybe like a trait perhaps, that can be used to wrap reads and writes from the file and see what we get. So I just want to make sure nobody had written anything. My chat is looking a little bit weird. Okay. The thing is, I think it's going to disappear. You know, with this new screen resolution, I'm not quite used to where. So you can see the window popping over there a little bit. Yeah, it's so big. Zoom out. There, now I should be able to see everything. Okay. Okay, so so we could look at the raw snappy encoder and decoder, or we could look at read and write, and we may need to use both. So let's look at the decoder. All right, so this takes, that's interesting that it takes a mutable slice. So we could use this. Yeah, they say it's intended to be a convenience method. I think that we might want to use this for memory efficiency. And then, right. So we would take the input and I don't know that we're not tracking what the uncompressed size is in the writer or in our file format. So we don't know how much to allocate for the output. And it might be better to do this for now. It's going to be less efficient because we aren't, controlling the amount of memory we're using, but it should be easy for the first pass. Okay. And then the encoder is the same thing, just compresses it into an output, and compress vec. So let's look at read and write. I think these might be better for us. Okay, so frame. Okay, so compressing data using snappy. That's not what we want. We want frame decoder. Okay, so this wraps a reader. So this would be used for our read side of it on the file. So we could take the file and wrap it in a frame decoder and then read from it. So that would be using the read method on this standard IO trait. Now, what's curious to me, and I think that we should look at the source about this, maybe, is like how did things like read exact work? Because what we want to do is like read the header of a block, we know that what the compression is, and then we want to read the first entry, we need to read exactly the length of what the header of that key value pair or posline entry is, and then read the rest of it. So that will be interesting. And I think that we're probably, using read exact already in our code. I'm hoping it will just work. So let's look at the source real quick. Okay, so read, I think, is the only one that you're required to implement. And yeah, and it looks like they're going in here and this is stateful. Okay. So this has the raw decoder that we saw in the other module, and a checksum. Okay. Source, destination. Okay, so it's got its own buffering, it looks like. I suppose that makes sense because starting out, it's not going to know how much it needs to read to get the amount that it needs to return to you. Okay. Okay, so these are like pointers into, or indexes into this output buffer, this DST buffer. Okay, cool. Okay. Right, so there's padding. Stream, I don't know if we will use streaming at all. I think it's probably a detail of Snappy that we don't care about right now. Okay. Yeah. So yeah, it does. You only have to. This is one of the neat things about this trait. Is that it provides default implementations for a lot of the, these methods, like read to end, read to string, read exact, and then you only have to implement read, which is good. Okay. Let's see about before we make a decision about how to structure this API. Let's see about going to another implementation of a crate, of a compression. Let's see if there's like a gzip compression library. There's a question in my mind about gzip and LZ4 because I think that it's in the works. Yeah, 4 years ago. I think that there's issues with licensing on those. So I don't know. Oops, not that. So there's zip. No. Yeah, that's not what we want. There's not one in the standard library. Interestingly, Erlang has one in the standard library. So now there's deflate. This might be the thing that we want. Okay, flate 2. Okay, supports gzip, zlib, deflate, right? Because they're basically variants of the same compression algorithm. This is pretty up to date. I think that this is a good place to start. Okay, so let's look at their docs. Okay, so this is probably best. We could link against libc, but it might be best to not have a dependency on a system library. Okay, so this also implements read. Okay, so let's look at what the interface is on this. Okay. Raw in-memory compression scheme. This is gz builder. Okay, so this is about writing an entire file, it looks like. And we're not concerned with that. We're only concerned with using that compression method directly. There is, okay, so that's something we can't construct. So let's look at compress. And this, okay, so there's some constants like none, fast, best. This is probably something that we want to look at the Erlang code and see what they do. But we'll probably pick like fast or best for this. Okay, let's look at the Erlang code real quick. So on gzip, it just uses the default settings. So we pull up Erlang. Oops. Set a zip, gzip, zlib, gzip. Yeah, that doesn't even have any options on it. So, okay, so that does compress with gzip headers and checksum. So I wonder how we do that here. Let's look at this crate a bit more deeply. Okay, so there is this gz builder. Let's look at this again. Okay, blank builder with no header by default. So, okay. Let's see how this works. So we create a new one. We're not supplying any of this information. You can use write and read on it. So this is, I'm assuming, yeah, so these are the IO write and IO read traits. Okay, so this creates a writer encoder, which is what we want. And then, you know, on write, you know, this is in standard IO. We can flush. So we'll want to have probably a buffer writer, like a writes to a vec, right? I don't know that vec of U8 implements write, but we can look into that. I would expect it to. Let's look at Rust. So standard IO write. Let's look at vec. And let's see if it implements write. You know, it's probably buff writer. Let's just look at this module. There's probably something in here. Yeah. Okay. Wraps writer and buffers its output. The thing is, we don't want to necessarily write to the file directly in the writer, but we might want to do that eventually. So let's look at the writer real quick. And I think that when we're in here, you know, we're writing the entire thing, right? And then we call write all with the buffer. So maybe what we should do yeah. The interesting thing here is that this part we kind of need to excuse me. Maybe what we do excuse me, goodness, is we, you know, we push the problem is we need to be able to compress. So if we can compress to an empty buffer and then we know the size, then we can write each of these things to the file and then and then append the compressed body of the block. Interestingly, I think that there's some other things we need to do here, which is when you open the database, you should be able to select what kind of compression you want. We should be able to read any kind of compression that's set, but for the writing side, you should be able to pick it. Okay, so I'm trying to get on track here. Let's look at compression. I'm pretty sure that what we want is we want something on this compression struct, which will give us back a reader or writer for that kind of compression. So I'm just going to stub this out, and I'm going to say this is pub reader, and I think that we want to have an R here, which is impulse standard IO read, right? And this is going to return something that impulse standard IO read, and that'll be the kind of common denominator of and this needs to have self. Can you hear my cat licking my arm there? Okay, so now what we can do here is for none, we can just return the original reader. There is a question here of I think that this needs to be borrowed. Does it need to be borrowed mutably? Because I feel like the problem here is these are not going to return the same type. So what we'll need to do is instead of that, we're going to say box dyn standard IO read. And maybe this will also be box dyn standard IO read. I don't like specifying that so strictly, but in order for this to work properly, we need to be able to treat these things as the same type. And then let's do one that's the writer as well, and basically follows the same thing. Now we could potentially just say this is impl, and then the caller wouldn't need to box it, but then we need to box it. Yeah, let's do that. I like that better. And this will let us transparently wrap these compression methods. Okay, and this is going to be box dyn standard IO right. Okay. This may not be the method that we eventually use, but I think it should be sufficient. Okay, and then let's fill that, and here we'll just do the same as above. New of W. Okay, so now let's instead of that, let's do W standard IO right. This is the same thing. I'm kind of curious about why. Why that it doesn't like that. Okay, but this is owned. What's going on here, REST? Parameter type W may not. Okay, so is that it? Do we need a lifetime parameter on it? Okay, that's what we need. That's ugly, but we'll do it anyway. It's really just saying that we need to correlate that the lifetime of the thing we're returning is related to the lifetime of the thing that was passed in. So it's sad the compiler cannot figure that out for me, but I'm actually going to revert. This is not the thing. Is it like that? Okay, it likes that. Then we'll do plus tick A, plus tick A. And so this is just saying this thing that we passed in has this lifetime, and the thing that's inside the box also has that lifetime. Or it lives at least as long as that. So then it doesn't mind us creating a box around this thing that it doesn't have any lifetime information about. We're kind of assuaging the compiler's worries there. Okay, so let's get Flate2, and what was this other one called? Snap. Okay, so we're gonna cargo add Flate2 and Snap. And I think that there's a question about whether we should make these optional. probably is the answer. And then we would need to put that in here, that like if we have Snappy, if we have gzip. And let's go ahead and find an LZ4 crate while we're at it. No, I don't want that. Crates.io. Okay, let's see if there's an LZ4 crate. This is a binding to LZ4. Here's one that's in Rust. That's probably what we want to do. Look at how many downloads that is. This is updated 2 months ago. This is updated 8 months ago. I think either one is probably fine. LZ4 Flex. Ha ha ha. Okay. Pretty good compression and decompression rate. Okay, let's look at LZ4 Flex. Of course, so this is to be expected. IO read and IO write. Frame decoder, frame encoder, so forth. Okay, so we'll want to use the safe encode, safe decode. Yeah, those are all enabled by default. Okay, so they're saying for maximum performance, use no default features, which I'm assuming uses unsafe code to do that. Okay. That's an interesting difference. Compress into. Okay, let's look at block. I think we want to kind of keep the same pattern. Yeah. Okay, so let's look at frame encoder. Finish. Okay. Yeah, let's get this one. Let's add LZ4 underscore flex. Okay. So now we have all of these compression methods. For now, we're only using this. So what I'd like to do is go to the areas where we would have to deal with compression. So both on the reading side and the writing side. And figure out what we need to do there. The writing side is probably easier. So if we're here in the writer, I think we need to deal with this first. So let's have it write the header, and then we'll have it. No, let's have it compress to a buffer. All right. I wish I had looked this up ahead of time, but you're going to see me do some Googling. Okay. Rust. IO write to vec. Okay. What do they say here? It implements write, but it defers to derest it. Okay. So implements read. Okay. So we can just use vacuate. I thought so, but like the docs were not clear on it. So what we can do then is say, this is the final block amount. I think what I don't want to do is go, let's rename this to buffer or to header. Because this is what we're going to write the header into. And I think that block.size is not necessary. We just want 8 because that's okay. So this is 4 bytes. Level is a U16. That's 2 bytes. Compress is this. So we actually only need 7. The tag end, I believe, is part of the compressed. Oops. We're going to look at how the Erlang code does it. It was encode index node. Okay, so they actually prepend the tag end byte, right? So that is not part of the header. This part gets compressed, right? And then they put the method name on the front and so forth. Okay, so this becomes part of the contents. Now the block size is like the uncompressed size. We've been recording that as we go. So what we can do then is we could say the header only needs to be 7 bytes, but let's do contents is vec with capacity block.size. And what we'll do then is we will rewrite the block size after we know how long the contents is. And we'll have to make sure that this is being used correctly everywhere. And this is incorrect. Okay, so this will be, this is contents.len, and we need let me look at the design diagram real quick. I think that the block length does not include itself. Right, it includes the level, but it does not include the length. So the level and the compression. So this is the part, the compressed data. Right, I wish I'd looked at this first. So we have 3 bytes plus the length of the compressed data. So we have contents.len plus 3 bytes. Okay, so we're going to move this up here. And what we're going to do is do self.compress, see, let mute writer is self.compress.writer, and we're going to pass it contents, I believe. Or we don't just pass it contents. So this is going to be interesting. I wonder. Yeah, that's not going to work. So we're part of it is that we're using it down here. The question in my mind is, can you do this? Mutable, yeah. We need a way to know how much was written. And maybe what the answer to this is we just pass it in here, and then we keep track. So let's say contents length. Okay, so we're going to do writer. We're going to do write all. And entry encode gives a vacuate. Excuse me. Okay, so the other thing is this returns a result. Okay, so this is how we'll do it. Not really elegant, but what we'll do is we'll do entry, let entry is entry dot I call it encoded. So we'll do entry dot encode, and we'll do this is encoded, right? The problem is write all, does not return the length that it wrote. So we need to track that here. Encoded dot length. Okay, so contents. Well, okay. So honestly, this is we don't need to hold on to this. We can inline that. No, can you inline? Okay. Okay, and then we can get rid of that. Okay, that's not the most elegant. Okay, so we are passing into the writer The problem in this case is we also need what it wrote in the end. And I think as long as this is wrapped in the way that we've chosen to do it, I think that's not correct. So we probably need a we need something else. And this pattern is not sufficient. We need to hold on to ownership of this thing, but we need to potentially have a compressor around that is able to write the design of this is it's fighting me. Okay, so by the way, this does not belong in here. We need to say it's one, and we need to writer.write. Can I write a single byte, please? Write all? That's probably what it is, yeah. Okay. The other possibility is that we pay the cost of having two buffers. Rather than having like these entries just kind of come and go, we write them to the entire block and then we compress the block. That's probably the simpler way. So let's refactor. I think that like I'm running into too much friction here. So let's do we'll leave those methods around. Let's just say compress. And it's going to take a input is going to be a slice of U8, and the output is going to be a result of a vec of U8. Okay, so let's do this. This one is going to be easier. We're going to say this is okay of input.clone, right? Oh. Too back. So it just reallocates it. It's dumb. It's inefficient. I wish we didn't do it. The other possibility is that we say this is a vec of U8 and it's owned. And then we're able to go, okay, well, it's just input and we don't have to clone it. But for the other things, you know, it's probably going to allocate a new one anyway. So I think the expectation here that this is returning a vec of U8 and not something that is borrowed is, yeah. So let's think about that kind of interface. Okay, so okay, we're going to say let mute contents is a vec with capacity block.size. Okay, and then we don't need this anymore. We're going to say contents dot push tag end, right? And then we're not going to bother with tracking the length. We will just contents.extend entry.encode, which is basically what we had before. And then we can get rid of all this. And then before, let's say compressed self.compress.compress. Not the most elegant looking thing. And then we'll pass it contents. So we don't use contents after that. And here, rather than block.size, we say compressed.len. And then we do self.indexFile.write all compressed. So we're doing basically what we did before, but we're doing the compression. This removes this to do. This interface is potentially not the most efficient, for sure. I do have concerns about it, but it's fine, right? We'll have oh, right. So we need to put a question mark there, right? And this is compressed.len. Okay, we don't need the A there. Okay, so now we've basically compressed the contents. And now we get to go implement those things. So going over here, we're going to just comment these out. I would really love to have the more efficient ones, but we might be able to have it on the reader side. On the writer side, it's a little bit trickier because of the, I don't know, the like needing to know the output. We should be able to revisit that later. Okay, so let's make a new folder in here. Just compression. And maybe we don't need that. Let's just do it brute force for now, and we can refactor it later. Okay, so we've got gzip, right? And let's just go ahead and do these, right? Okay. So for gzip, let's come back to that. Let's do snappy. Okay. So we can do write frame encoder. Again, we're running into the problem of, let's look at the raw encoder. Right, so this gives us some max compress len. Where is that max compress len? I don't see it anywhere. Okay, so I'm just gonna make a block here, and we're gonna say let mute output is vec. Say with capacity input.len, right? So we're just making a new one that is at least as long as this. So it should be smaller. If it's not, then we have a problem. Okay, so we're going to use snap raw. Let's just use snap raw encoder. Oh, here's a function. Let's look at that function. Max compress len. Okay. Okay, so it's giving us an estimate of how big this output buffer needs to be. And then we go back here, encoder. So let's do snap raw encoder new. Honestly, we do this compress back. Remember I was talking about the the quickie way? We're doing it the quickie way. Okay, so we're going to say compress vec input. Now this is going to return a different kind of result. So we're going to need to look at their result type and their error type. Okay, so we need to make one that comes from. So we'll do like so, and put the question mark in here, and then our error type needs to snappy compression error, and then we say snappy compression, and that's from snap snap error. Okay, easy enough. And then over here, you know, we should get, yeah. Okay. So that'll convert our the snappy error into our error, and then we're all good. Okay, and then so that's easy enough. On gzip, let's look at Flate2. And we'll start with something like this. We're going to need a vec to write into. So okay, let's look at the GZ encoder. Okay, so you can get a reference to the underline writer. Oh, so this returns the underline writer, which is fine. So okay, the kind of like write some things incrementally. When you finish, you get the underline writer back. That's actually a really good pattern. I wonder if Snappy did that too. If it did, then we can probably go back to our other way. Let's look really quick. Otherwise, we're gonna move on. Yeah, there's a get ref and a get mute. You can do into inner. Yeah, that's probably okay. Cool. So the problem is that's not consistent. So we will probably want to make our own trait that will call into inner or finish on whatever thing. And we should look that LZ4 does something similar. I would not be surprised if it does. Now, it's interesting that both of these crates have these get ref and get mute. Okay, cool. We have a way forward potentially that'll be more efficient. Let's finish this way, and then we'll go back and make the more incremental way, which might be better. Okay, so right, so gzip, we want to make one of these builders. Let's say writer is going to be Flate2 GZ builder. Okay. New. And then we don't care about we don't care about these file name comments, etc. I suppose we can use compression default for the first pass. .write, and we're going to say vec with capacity, input.size, or input.lem, right? So we need at least that, and Flate2 compression default. I can probably just do default there. And does write return? No, it just returns it straight up. Okay, so then we can do writer, write all, input. And return a question mark there. And then we do writer dot, oh, we need a finish. Okay, so we kind of want to do this. This needs to be mute. Okay. So I'm actually surprised it's not complaining about. So let's look at this. Like what is the what is finish return? It returns an IO result. Okay, and so we're already handling IO result. I was wondering, I was like, is there some special, Flate2 thing there? No, there is not. Okay. So let's do LZ4. And we are making good time on this stream, surprisingly. Okay, so this has a frame encoder. We don't want finish on drop. Okay, the finish returns, the inner writer plus their error type. Okay, so we need to make a, let's go to the error. LZ4 compression error and LZ4 compression, and that's gonna be from LZ4 flex error. Okay, it doesn't know what that is. Let's see, LZ4 flex frame error. Okay. Now, back over here. Let's do basically the same thing that we did for the others. So we make a frame encoder. I think we just do new. We don't care about the frame info necessarily. We could tweak this later. I don't think we need to do it right now. These block size, we'll use auto. That's probably the default. Block mode, don't care. Block checksums, of course that's a bool. Sorry. Content size. Total. Okay. I don't really think that that's necessary for this. So, okay. Oh, well, we can just do that. That works. We just say, okay. Borrow it. Okay, so that was a little bit anticlimactic. Okay, so now what we need is we need a decompress function. And I think that when we have those two, we can do the very basic read-write cycle. And then if we want to get more efficient, we can do like the give me a compression reader, compression writer. And probably what it will be is we'll have a trait that implements the things we want to use. And then we will create types for each of the compression strategies. We'll implement that trait for those types. And then this, enum here will just be like a give me a codec for this thing, for this type of compression. Right now we're kind of overloading this thing, which is really just a marker in our data. Okay. So let's get rid of those for now, and let's make a decompress self. Okay, and then I think this one we want a result, and this actually will take. This is probably going to take a reader, I think. I don't know another way to do this. Now we could give it the whole block, I suppose. Let's start with that. Okay, input is not going to be input. We cannot say it's owned necessarily. Let's go ahead and implement this, and I think then we'll come back and see about another way, better way to do it. Okay, so that's just, it's reallocating the input. Dumb. Okay. So let's look at what Snappy needs. Here we are again, Snappy. So let's go look at their, I think we're using raw decoder. Okay, so theirs is easy. We do decompress vec. Sorry, decoder. New decompress vec. And that takes input, and then we put a question mark around it and an OK. Done. Okay, so that was basically the reverse of this. And let's look at Flate 2. So that was the encoder. So we need a do this GZ builder business again, I think. Okay. Reader. We might not need it to be mute, but just in case. GZ builder. New. Now we have no way. Let's look at decompress. Like, this isn't actually too bad. I wish the other ones had worked that way. Okay, let's look at GZ Builder. I'm not sure what the difference between, oh, so that's buff read versus read. Okay, we can't guarantee that what we're, yeah. What does buff read do? Fill buff. Okay, has data left. Okay, so this is the read interface. You know, we're not really using the... It's interesting there's this whole GZ builder thing, but we're not using it directly, like, because we're not setting any special header things. So I wonder if on the right side we can just use GZ encoder and create one. Yeah, let's simplify that. And we give it that. Okay, then down here we can do read GZ decoder new, and we read from input, and we use the default compression. Okay, what's wrong there? Oh, it just takes input. Right, because it's decoding. Okay. Right. Okay, that's fine. So now we need this is right. We want the read module GZ decoder. This implements the read interface, so we could do like read fully. Is that a thing? Read to end. Okay. So let's do. The other thing is we're not going to be able to know how much to allocate ahead of time. So let's do this, and we'll just do vec new, and then we do reader read to end, and we give it mute contents. And I think that's it. We don't need to finish. Yep. And then we return OK contents. Okay, so we need to put a question mark on that because we're reading to end. Okay, so then I think that there's going to be a decompress method on LZ4, just like on the previous one. So let's find out. Decompress. LZ4 flex. Come on. Decompress. Okay, so I think we need to compute the minimum uncompressed size. And I think that was just a function that they had in there. Let's see, block. Yeah, it was around here somewhere. C4 flex. Block. Saw this just a minute ago. Where was it? There were some functions. may panic if the parameter min uncompressed size is smaller than the uncompressed data. Brilliant. So we need to get, no, this is the maximum output size. Decompress into okay, so we have a potential problem here. Like we did compress, which maybe we need to do compress prepend size. Then we have the compressed size at the front of the buffer, or the uncompressed size. Let's switch this up. Yeah. So this is compress prepend size, and then we can do decompress size prepended, and then the first 4 bytes are already in there. This is kind of a, I guess it's fine. Okay, so we need another error. Interesting, that was frame error. I suppose we could do, you know, if it implements buffer, it implements read. We could do read to end rather than this other thing that we're doing. It'll look more like the gzip example. Okay, and then we do that. Yeah, I think that this is the way to go for that one. The I wonder about if this is going to read only a single frame. I think no. Which maybe we need to do, use this instead. So it looks more like the gzip on this end, because I think this compressed prepend size is just a convenience. All right, let's do that. I want to make sure that this is consistent, that we're using essentially the same but inverted method for each of these things. So we're going to do let mute writer. It's LZ4 flex frame encoder, new, and I think this has the finish. Yeah. So we're going to give it a vec new. And then we're going to do writer.write all input. And we'll say, okay, writer.finish. Okay, so then it's very much in parallel to, and I mean, I think we can probably use their helper functions to know how big this thing should be. I mean, we can just give it input.len. That's the dumb way. I think they had some, was it in block? Get maximum output size. Okay. And then we'll say this is the capacity. Rename that capacity. Okay, so what's going on there? What did I do wrong? Oh, I need a semicolon. Okay. So now over in the writer, we're still using this straight up compress the thing. Hi, Isaac. I'm sorry I didn't see your message. Wow. The chat's way over here. Welcome to the stream. Okay, so what's wrong with incompress? It's just saying we're not using decompress. We are using compress. So now we need to look in all the places where we're reading. And I think that it is mostly here. So rather than a file, we need to be able to pass a reader here. And I think some of the stuff in here about tracking how much we've read is going to blow up because we have those iterators, which they're just tracking, you know, where did you start and where did you end? Did we reach the end of the block? But here we're tracking decompressed bytes potentially. Now the other thing that we could do is say yeah, this whole thing is going to have to be rewritten. Well, not necessarily. Maybe what we do, let's look at probably block. We need to give it the compression as well. Yeah, I think like this is pretty obviously challenging the design that we had before, where we just read straight from the file. We kept our offsets into that file. and then yeah. Okay, so maybe, it's going to have to be in all of these iterators. Um, maybe there's a constructor. Because if we are doing this, decompress thing where it's not a stream, it's not a reader, essentially. Um, yeah. Okay. So we need to figure this out, I think. Because what I would love to do is maybe over in here, we make something like an entry reader, which wraps either the file directly or like a decompressor. And then we use straight like IO read methods on this. Because we want to this is let's see, what is it returning down here? Right, so it's returning how much did I read in uncompressed bytes. But what we need is how much did I read in compressed bytes if this entry iterator is supposed to work correctly. So we need this whatever the input is here to be returning how much did I read. And I think the standard IO read trait we're in here. Maybe what we want is this buff read. Has an internal buffer allowing it to perform extra ways of reading. Right. So it can implement read. Yeah, let's look at the read trait again. Because what I want to do is do like read exact. But no. know how much was read from the compressed part. Now we could do something like this bytes iterator. Yeah. Which, I mean, that's sort of like we would do, you know, something like, you know, do you take for individual reads? That's a possibility. What's this read? That's nightly. Never mind. So, yeah, this read method returns how many, you know, you pass a mutable buffer in, it returns how many bytes were read. It does not tell us how many compressed bytes were read. So if we could do something like, let's look at Snap, for example. So if we were to use their read, so we would do this frame decoder, we'd wrap it around the file, and then it implements read. I'm actually surprised it doesn't implement buff read. Now, what I wonder if there's a way we could say to get a reader from the file. I mean, you just need to wrap. Yeah, this is what I was thinking originally, and I didn't quite figure it out. But I think we need a reader that we can wrap the compression algorithm around, that will track when it's reached the end. So yeah, I think that's the answer. All right, let's do that. Okay. So rather than have the iterator, so like this is back over with block. Rather than have the iterator track start and end, we'll just give it a reader which is bound to this start and end, right? And that just basically says here's a reader scoped in this file that is within this block. Yeah, I think that's the way. That's the way. And then it can use the compression. Yeah, let's just make this little thing. So, okay, so we're gonna say struct. It doesn't need to be public at this point. Entry reader. And and it's going to have a file, which is file. And it's going to have a start U64 and U64. So it's looking like those iterators we already have. But this is going to be an owned entry reader. Again, this is about like, do we clone the file or do we burn it, etc. And then we'll have, and this is going to be really, interestingly, are we using this anywhere? Final references. We're using it in trees. Okay, and where we're using entries owned. Just in this iterator. Interesting. Well, we're doing it over here. Right, okay, so those are all like cascading up with this, the owned versus not owned. Okay. So this will be, and this needs a tick A on it. Tick A, file, etc. Start, end. Okay. Let's start with the owned one because I think it's going to be easier to deal with. It's going to impl read for owned entry reader. Okay. Yeah, so we need to do read. That's the required one. And what we will do is here we'll return if self.start greater than or equal to self.end. Right, so we're just bounding this reader to the block that it cares about. Then we're going to return OK 0. Else we're going to defer to the file read. So self.file.read. So we're going to read, we're going to do that. If it's okay, some length, then yeah, we'll get to the error. Maybe we'll do, yeah, this is fine. Okay, so what we need to do there is self.start plus equals length. And then okay, here, let's do a little trick here. Okay, let me say okay. Len is U64. Okay. So then we basically do the same for the entry reader. So let's just copy that. And we need tick A on all that. Okay. So now we have these, and these bound the scope of the block. So we can change our iterators to this rather than having the file. Sorry about that. Rather than having the file, this has an owned entry reader, right? Um, or it has just a reader. Probably that's okay. Yeah, yeah. Um, okay. So let's look at maybe we can unify these. For now, let's uh, interesting. Okay, before we tackle the iterator, um, both of them, let's look at, can we get our original thing to work out here? So I think that let's get a reader, and this takes R, which is impl reader. And I think we have to do that lifetime thing plus A, because we need to get this to be a box dyn. This is standard IO reader. Standard IO reader plus A. Okay. So we're going to match self here again. Okay, for none, we just return box new of R. And oh, read. Okay. Genius, that one. Okay, so for snappy, then we do something that we did like this. So yeah, so let's do okay flate2 read gz decoder, and this is, we need to box it. And this is going to take the reader. Helps if I do new there, right? Except I don't need okay. Okay. I don't know why I was doing that. I think I was looking at the stuff above. So that is actually, this is to do. That's actually gzip. I messed that up. Okay, LZ4 will be similar. It'll just be this, right? R. Okay, and then we need snappy. So let me look at the docs for snappy again. Okay. Snap read frame decoder. Okay, basically same thing. Okay, this is kind of what I wanted from the beginning. It was not obvious how to use it on the writer side at first. On the reader side, it's probably easier now that we're getting these, the entry reader and writer, and we implemented the standard IO read for those. So now we need to redo this. So I think that what we want is for the entry iterator, There's a question about whether this actually applies anymore. Um, I want to look at where these are used. So let's look at this again. Right, so that's in the test. Let's look at what it's doing in here. So get entry iterates over entries. And the only reason we have this difference is because we were like, are we cloning the file handle or not? Because the iterators themselves always return owned entries. So there might not be a distinction anymore. Right? Now there is the question then about file seeking and so forth. And maybe these readers. Oh gosh, I would love to unify these things. The fact that there's two of them, it really bugs me. Okay, so yeah. Where is this used? Own tree entry iterator. Okay, so this is like loop through everything in the. Where is this used? That's used in the merger. Okay. That's good to know. Where is this one used? Only here. Okay, so honestly, we only care about the... Yeah, and that's why that says dead code on it. I don't think we're even using it in tests. Nope. Okay. We've got less than 10 minutes left. Let's see if we can get this narrowed down to just owned iterators. So I'm going to get rid of that. We're going to rename this to entries. Okay. Okay, good enough. And then let's see about getting rid of... Yeah, see, this is like, hey, it's dead code. It's interesting, these are basically the same code. That's the other thing that bugged me about it. So let's get rid of that. We're going to rename this to tree entry iterator. Save everything. Okay. I love that feature of Zed. Oh. Here, wasn't I renaming that? So tree entry iterator. Okay. And they're all named the same thing. So there's no... What file's unsaved here? Let's just save them all. Okay. So we got rid of some complexity there. And I don't care about that. Okay. What are the warnings in here? Yeah, never constructed. Fine. Don't care. Right. So we're about to get rid of the unowned ones. And just do all owned. Okay. So let's find all references to this. So tree. I don't see any reason why we can't do entries owned here. It's going to change some things, right? Like this is first keys of X, so we can just do borrow there because it derefs. Okay, well, there we go. Okay, so that wasn't so hard to fix. I'm curious why that returns a result, but we'll figure that out. Okay, so now over here, are we using this anywhere? Using it in trees. Entries owned. And this comes down to the, yeah. Okay, because that's like, can I clone the file, right? Can I clone the file handle? Okay. That's not so bad. Then over in block, oh, this is like, yeah, hey, dead code. So we can delete this. And let's rename, okay, so entry reader we're not going to need. We need own entry iterator, but we're going to rename it. But we're going to get rid of the entry iterator. Okay. Excuse me. Let's rename that to entries. Save that everywhere. Okay, and then down in the test here, we need this unwrap, right? Okay. I swear by the end of this stream, we will run the tests. Okay, so I'm going to rename this to entry reader. The other thing we could say here, let's rename it again. Block and contents reader. I don't know. Contents reader. That's probably better because this is like, hey, read, but don't include the the headers. Okay, and we're going to rename. Where's our own entry iterator? We're going to rename this to entry iterator. Okay. Now, the other thing that this needs to do is this seeking code needs to go into this read, because if this file pointer has been moved by anything else, we just need to make sure that it is seeking to the beginning. So this bit that's happening in the iterator down here, we need to handle. So let's put that in here. So if we seek the file, right, and then okay, so this will be just saying, hey, we can't. Actually, that's not true. We want to handle this differently here. We would just want to do that. We want to always seek to the start when we go to do a read. Okay, so this entry iterator is just going to, we'll fix this in a second. And here, now we don't need to track. Entry read does not need to return how much it read. Because that was for accounting of how far did we get through the file. But the reader, the block contents reader, is it is implementing that for us. It's tracking that for us. I think there's a code action. Yeah, let's just do this. And then we can remove this else. I like that a little bit better. So we're handling the two edge cases at the beginning. And honestly, this probably needs to come before the seek. Because we don't need to seek the file if we've exhausted the contents of the block. And then we're trying to seek to the beginning, and then we read. We could do something like let result is this. And then we say, we'll just return result at the end. We say if let OK len is result, then we'll do self.start plus equals len as u64, and then we just return result. I could probably do map on that or something. Let's see if that works. And I'm sorry, I'm tweaking a little bit here about yeah, there's no distinct advantage for clarity there. Okay. So entry iterator no longer needs the file. It no longer needs start and end. We're tracking that. So let's make this just a tuple. And this is going to be block contents reader. And that is not public, that field. I think it's important that it's not. So now we don't need to track this. We just do, we call entry read self.0. And it needs to be mute. So we'll do this. And we don't need that anymore. So essentially what we want here is entry read, and it's going to take mute self.0 .ok, so that if it returns an error, then we convert that into none. Okay, so that's going to be like, I don't know what you're passing there. So let's go to that definition and fix that. And this is going to be right? And again, that doesn't need to be mute there because, okay. So I think it's complaining over here. Right, so entry read only returns result self now. And let's go down here and entry, and we don't need to track that. So let's find all the places that we're tracking that length. That's fine, probably. Yeah, because we're using that to allocate a vec for the data. What is still wrong here? Oh, we're not constructing it correctly. So now what we're going to do, and actually this is not necessarily correct. This is going to have a box dyn standard IO reader, right? Where this might get problematic is that what we've done here in compression is that we have this lifetime on it. Let's find out. Okay, so now we're going to do let's do a interesting. We might not need the triclone anymore. Let's find out. Okay, so we're gonna do there's a decompressor. Self compression reader, and I'll give it file. Okay, well, no complaints yet. Let's see what our errors are here. Right, so we're gonna have to look in the nursery. Now this, okay, so first of all, it's gonna return a whole entry and we don't care about the length. So here it's like mute unknown found file. Like so forth. Okay. There we go. Okay, so that signature lines up. What are the warnings? That's interesting. I didn't expect it to happen in there. We have unused imports. Okay, we're gonna replace that qualified path with use. We don't need file in here anymore. Okay, what other warnings can we clear up? We're not using decompress. Oh, right, we need to do that. We need to do that correctly in the block. So I was doing just read from the file, but that's not correct. What I need to do is block contents reader. Start is self.start, end is self.end. Compression. Okay. Okay, start. Oh, right. I need to look at what we had before, and then we'll finish up real soon. I promise. Let's just look at it, what it was on the website, because I had some computation in there that was right. Self start plus 8. Yeah, so let's just copy this, which is what we want to do. Okay. Okay, so we have, I think, successfully refactored this such that we can read entries incrementally through the decompression algorithm, which is pretty awesome. So now let's see what the warnings are over here. It's just dead code. So I think we're not going to use this. This is the only place we compress is in the contents of a block, right? So the key value entries in there, or the inner node entries, have to be read through that compression algorithm. So there's no sense in decompressing the entire block. It was something I wanted to avoid. It also means that you'll note that when we were when we were doing the changing entry here, we just had to change this to be, yeah, I'll take anything that implements read. I don't need the actual file, because it's just like, hey, I'm going to read an entry. And then the things on the outside, like the block, can go, here's the bounds of the contents of my block, the contents of entries in the block. And I'm going to create a compression reader for that span of the file. And it doesn't have to care about what the underlying file is. So that is turning out pretty nicely, I think. And let's replace qualified path with use. And I have it there twice. Okay, so now there's another issue here, which is we cannot read that because now it's compressed. Remember our diagram over here. Compression includes that leading tag end, so we cannot verify that. Let's look at right, so those first 8 bytes. The problem here is that it's actually 7. And I think, yeah, let's do 7. And then before we pass this off, I need to read one byte and ensure it's tag end, right? Um, we'll do read exact. Okay. So I'm going to make okay. So we're gonna make a vec of a 0 byte, and then we're gonna do decompressor dot read exact, because we need to check that this question mark. Okay, so we need mute here. Okay, and then we need to, if tag is tag end, tag 0 is tag end, then we return this. So like we need to consume that tag byte, otherwise the entry is not going to read correctly. And then we'll put this check that we had in the constructor up here down into here. And now we can do that. The other case that we need to check on this, note that now this actually doesn't matter. This block line equals 0 because we were doing that preemptive check. We can simplify that. Now we need to check down here in entries, or maybe in here. Yeah, I think because we were handling the case where the block length is 0 up here. Yeah, let's handle this a little bit differently. Okay, so I want to do match on this. If it's okay, if tag 0 is tag end, then we want to, no, let me simplify this. I was starting to make it too complicated. What we're going to do is an early return. So if self.blocklen is 0, then we're going to return OK, the entry iterator decompressor. Because what does this mean? You're going to get the end. This is 0. So start is already going to be greater than end, and this iterator is just going to yield nothing, right? That's fine. I might put a little safety thing here. If the block len is 0, then reading from the block will never fill a buffer because start greater than end. So we don't need to check the tag byte. Therefore, we don't need to check for the tag byte or advance the reader at all. Okay. It's not technically safety in the Rust sense of safety. This is like safety in the sense of there's this invariant inside the block contents reader that if start is greater than end, will always return 0 bytes read. I think that's not what I wanted to do. The interesting part might be the kinds of errors that can happen. Yeah, there's this error kind thing, but I don't know that I want to do this. Yeah, this is not relevant. I think we just want correct behavior. Yep. Each block that has entries contains a tag byte at the beginning. So if that is missing, then we can't read entries. If it is present, we need to skip it. Okay. Okay. So I think that's yeah. I think that moves that to the right place. And as my parting shot for today, we're going to see if we can run the tests. Let's look at that warning first. See what's oh. Okay. I'm probably going to break. Yes, see? I broke a bunch of stuff. Okay. And yeah, some of that may be just we are using a... So this panicked with an assertion failed. Okay, we broke some things. I think This is a good place to start next time. So let's make, yeah, we did a lot. Okay, so we're in session 17. We need to fix those test failures. And I think some of it is just that we moved so many things around that it's not going to work anymore. So we're going to say initial pass at compression, decompression. And then later we could potentially use feature flags to turn off and on particular kinds of compression, so you don't have to download everything. You can just select the compression types that you want. And I'm gonna push to main, and that is, next time we'll look at these test failures. There's some problems here, obviously. So we need to handle those. We also need to add tests for the different kinds of compression, just to make sure that some of the things that we have already asserted still work. So we will do that next time. Thank you everybody for coming, and I hope those of you who are in the US have a happy holiday this coming week. If you're not in the US, enjoy your week, and I will see you